Okay. What's up? What's up? Oh, it looks like my mic is quiet. Give me easy effects. Input, output, input, recorders. Yeah. I always gotta crank mic aux. Mic aux. That's 2 words to be clear. All the way up at the beginning of my streams. Anyways, what's my analytics? Let's get the Commodore up, shall we? Computer C64. And let's get boop, 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 boop. Come on. Make sure we're on standard. And let's get it to NTSC. Now, finally, can reset. Okay. So, here we are. Let's do 10. Print. What should we print? Welcome. Okay. So here's where we really are. Oh, this is my analytics. Oh, dude. Okay. I posted this short. Right. I posted one short. Where is it? Control. Okay. I post one short. It does pretty well. I post another one. 6 views, dude. It's got fine analytics too, like watch times. Anyways, I don't care. Let's make some scripts. Here we are. Here's the diagram of our code. The plan is straightforward. What we're going to be doing is we're going to keep working on the network server. Let me get a checklist. We have several features we're cooking up. Let's go like, come on, zoom in. Okay. So, number one, we want to like send, receive, ping. Number two, send, receive data. 3, say the data is bad, corrupt, and say the data is good. And actually, I guess it'll be easier to check if it's good than to check if it's bad. So, oops. Let's get back to 20 10. Let's get back to work on that. Oh god, 20 go to 10. Let's see, run. I also wanted to take a moment actually to discuss, and actually here, let me get my stream open. Woof. Audio check. Audio check. Oh, it's still a little quiet. Hold on, let me turn it up some more. Sorry. Easy effects. Hold on, let me turn it up some more. Sorry. Cranked it a little. Okay. Effects. Sorry, cranked it a little. Okay. Yep, that seems good enough. Okay. Okay. Sorry, I'm having a little snack right now. I've got some Trader Joe's dried fruit going. It's yummy. I got some dried mangoes, some dried strawberries, and dried tart cherries. By the way, the mangoes, oh my gosh, heavenly. They're so good. But less, what am I saying? We have an innovation, a revelation. From last stream, we figured out that I can save my programs to disk. And it's been life-changing. Because now, here I can open. Okay, it's all loaded up. I can open up web server v1. What is it? Load $8. Boom. Web server is right there. And in fact, we can even prove it's there by saying load web server Now if I list, we get our web server program. Isn't that incredible? Like, it just works. It's just there. And it matches up just with our diagram still. But anyways, yeah, on this checkbox, just to be clear, we've made some good progress. We can send and receive a ping. We can send and receive data. Whether I can send data to the Commodore 64. I can't quite yet get data back. So that's what we're going to work on this stream. And then I'll add in, the ACK routines. Oops, just by the way. Let's go ahead and get to our program. Projects, Commodore, control from afar. Protocol test. Oh. It's handshaking. So, okay, so the program's running. It's receiving stuff. It received some data. It received some more data. And then, boom. It ended. Ended the program. Boom. Isn't that wonderful? Now, I had some ideas off stream about how to make my streams more visually interesting, right? Number one, camera pointed at the screen, at the Commodore 64 screen, like IRL. That could be cool. Number two, I could make it like print certain stuff in here. Let me just run it again. I'm saving its own ring, whatever, handshake bytes. Okay, now. Boom. So it pinged successfully, and then it finished. And to be honest, my Python's printing these strings. I forget what I had it print. But whatever, we'll get it to work. Oh, anyways. Yeah, I had some ideas to improve my stream's visuals, and I was thinking, what if I had like the background change? So here, how do I change the background? Hold on, let me shoop. Okay. I can say how to change background color, Commodore, or border color, Commodore 64. Okay, so it's poke 53280, poke 53280 with a 0. Okay, so that can turn the border red. Okay, so that's my idea. Is like every time we send or receive a packet, we can poke a different color into the border. Yeah? Like, what do we think about that? That could be interesting. I don't know. Just some thoughts. Poke 53280. I forgot the colors. 1, poke 53280. 2. That could be good for what's it called? If we're doing like bad packet. 284. I actually quite like that. 285. 53, 286, poke. Ooh, I kind of like that look too. 7. Ooh, that's disgusting. 53, 288. Poke. 53, 289. I know we've been through the color before. Poke. But it's still fun to walk through them. Ooh, poke. 53, 280. 11. Poke. 53, 280. 12. Poke. 53, 280. 13. Poke 53 280, 14, poke 53 280, 17, poke 53 280. And it looks like it, what's it called? It wrapped around. So for example, 16 is going to be, what's it called? It's going to be all the, it's 4 bytes for all the color codes, right? So 16 should be 0. Yeah. And then poke, 53, 280, 15. Doesn't look so bad. 280. What was the original? Oh, let me find 53, 280. No, 53, 280. Okay, let's just leave it at 0. That's fine. Okay. Okay. I'm dragging my feet. Because Loki, it's about to become a grind. I'm just being real. All right. So right now, let's see the flow of my little test program here. Protocol test. And it needs to be smaller. Okay, so we ping, and then we set it to the send data state. Quite frankly, I don't know why I did this state stuff. I guess in theory, it could retry the ping forever. But I don't know. Probably wasteful in it. But yeah. So it sends some data. Sends here's some more. Now, let's receive data next. So yeah, what we can do is, okay, so from bytes, it just makes what's it called? It just makes a packet from the bytes. So that means we can go, yeah, we can receive data pretty easily. So here in our program, where do I need to print to see this? Because okay, so I see our checksum printing, and then we go back to line 20. So let me list 20. Or wait, I have a flowchart for this exact purpose. So we open the network device, listen for version. Yep. So like then we start listening for packets. You know what? Instead of go to, we can send and receive ACKs. What if we how do we request until we're ready for packets? I don't know. Here's the thing. I'm building up this program where it's going to connect, send over a basic program, and execute it, right? Now, it would be nice to have that program send information right back. So I'm thinking we have, like, I don't know, Loki. So I was thinking, what if we have the network device just, it'll send like a request, like we add a new command here. We add a new command here that says something like receive packets, or something like that. But I realized what we could do is just kind of like, I don't know, always be accepting, because the flow of the program, I think, is going to be like establish connection, send over the file, keep the net connection open, and then it'll receive, and then the web server can just be in the mode where it knows whatever it receives back is data packets, right? So, okay. Just as a test, what if we say here, you know what? Okay, if line 350 is checksum match, send back an ACK. And then if checksum doesn't match, sorry, I'm a bit scattered today. This color. And circle. And here, let's move the hook over. Ugh. Sorry, y'all. Yummy. Anyways, make it white. It'll be line. It can be line 520, can't it? Can't it be 520? Did the interface change or something? Because it's like small. Yeah, it's because it was small, I think. Maybe? Yeah, it was because it was minimized. Oops. Yeah, so we can... Next up, we can say, yeah, send back a resend. And this is a check on, goodness, if the checksum doesn't match, right? If the checksum doesn't match, then say, hey, resend the packet. And then we'll have to like clobber whatever buffer we're building up. Yeah, send back a resend. And that's also line 350. Because we can say if it doesn't equal, or if they're equal on 350 here, the line my cursor's over. Oopsies. 350. If CS equals WS, then 500, else 520. So then 520 can be print to our network device. What is it? Packet ready, packet start, and goodness, what are you? You are... I forget what number it was. A web server, those are web server states. Commands, resend. Yes, so char 2. Let's say rem resend. And then also 530, we want to go to line 20 again to re-listen for packets. So we can run our web server. And then what we can say is we can send a bad packet, right? So we can say data sent equals packet command dot data, and then receive something that says says more, and then post after the fact. Ooh, here let's add a corrupt flag to it, because I want to be able to toggle if like this is a test packet and we want to make it corrupt. So yeah, here. Oh no. Comma corrupt equals false. Self.corrupt equals corrupt. And then here in 2 bytes, what we want to do is say if corrupt, then checksum plus equals 1. Yeah, we'll just add 1 to the checksum, which should corrupt any checksum, right? It'll always send a bad. It'll become a bad packet. So here we can go down. Data sent corrupt equals true, and then send, and then received. We'll say received packet. Let me zoom in for you guys. So we'll say the received packet is receive bytes from our socket, 2 bytes. And then we'll say yes, here's what we'll do. So we'll say resend requested equals false. And what I'm going to do here is I'm going to build a little loop that will like resend. It'll ask for the packet several times. Okay, so I'll say I want it to be resent 3 times, and then we'll say while resend requested is greater than 0, then what we want to do is create a corrupt packet. Or it'll be corrupt only if the condition, if resend requested minus 1 is greater than 0. So this should resend the packet 3 times. Print sending corrupt packet, and then it'll send it. It'll receive a packet back. If received packet dot command equals command dot resend, is that what it was called? Yeah, command dot resend, then resend requested plus equals 1. Or minus equals 1. When we subtract the number of resends, the number of resends we want. Yeah. Oh, and then else it'll just be print successfully sent packet. All right. Okay, yeah, the program's running. Might fail spectacularly. Yep, it did. Corrupt is not defined. Okay. It's because it should be if self.corrupt. Redial, please. Oops, that's rerun, re-edit the program. Okay. No attribute corrupt. Corrupt. Oh man, I can't spell. Corrupt. There we go. Redial. So it's doing handshake. It should receive a ping here in a moment. Yep. Hello from Python. Oh. Bytes object has no attribute command. Received packet. What do we receive? Wait a second. Receive bytes. Oh, that's because it receives. It receives. Okay. Oops. Receive bytes. We want to make a packet that from bytes out of the received bytes. And then we can try that again. Sorry, so what was happening there is it was just receiving bytes. It wasn't turning them back into packet objects. So what we did is we turned it back into a packet object and then, called it a day. Okay, so it looks like it's infinitely looping. That's not what we want, is it? It's also saying successfully sent a packet when that's objectively untrue. So while resend request, So if the resend request, here, let's print received packet. So we'll receive a packet, and then we can subtract the resend request. Run again. Because now I should be able to see on the Python side some more details about the packets, because I'm not sure why it was being buggy. Hello from Python. Hello some more. Sending corrupt. Okay, so it's sending it across from the looks of it, right? It's able to send a data packet across, but it's not able. Yeah, right. I'm not sure what the error is. Ready to more. Calc 17. Yep, checksum is 18, which means they don't match. In which case, here, let's do some diagnostics in the commodore. Whenever they don't match, we send or resend. And then I also want to print to the screen. What is it? Space, question mark, RESEND, space colon. Resend, and I forgot about quotes. So I had to truncate it there, or I had to shorten it there. Okay, so it's sending, it's doing the ring, doing handshake. Okay, so it's sending, we're able to send bytes across the wire in the form of structured packets. So here, if we stop it here, we can see it's calculating a checksum. It's not saying resend packet though, but it is going back to the beginning. And I think, is that because, that might be because we go to and then we print. It is, wait, no. Huh? Else 520, run again, wait a minute. Go again, little guy. Okay. That's so weird. I'm not seeing a resend request ever being acknowledged. Let's look. Wait. So we send some data. So we say, hey, we're sending corrupt. Sending corrupt. Here, low-key. We're just gonna minus resend at the requested at the end of the loop. Sending corrupt. Oopsies. Oh, sending corrupt, and we'll just put in resend requested into our string here. But frankly, I have a feeling this will make it work. We're sending some corrupt data over. And then we print the received packet. And let's say if received packet.command is a command.resend then yeah, resend requested should be minus equals to 1. And honestly, yeah, let's get rid of this. Let's get rid of this logic here, because I think this is making it fail. Corrupt true. And then we just want to send the packet here, just at the bottom. Corrupt false, or we can just get rid of it. So yeah, let's write that. And I am curious. I'm really curious. Why is it not working? Because it's printing. So 500. You know what? Here, let's rewrite these lines. Let's say that actually 510 is print 1, go to 20, and then 500 should be should say print sent ACK, or sending ACK. Yeah, and then this is line 530. Go to 20. Clear all that out. Yep. Get rid of that. And then on line 520, we say print sending resend. Okay, so if we list with a T our program again, then we should get, yep. So if the checksum equals the wire checksum, then we go to line 500, which just says, hey, print sending ACK, send the ACK, and then go to line 20, which just says start listening for packets again. But checksum is not equal to wiresum, and go to line 520, print, hey, send resend, and then go back home. So if we run this, I should also be able to run my, I'll say should get ACT. And then here, I'll receive some bytes. YJ. Oh, we need to send our data sent, don't we? Okay, now when I run this, it should work. And also, by the way, I've been having this idea. Okay, so the era of the Commodore 64 was very much defined by things like BBS, not defined by, but a big part of computing back in the day was like, oh, it's in a loop sending corrupt data. Interesting. So it goes to calc 17, and then it says sending ACK. Byte is 1. I'm not sure. Let's look at our checksum calculation, because maybe something is off there. The wire checksum, we're subtracting 1. Interesting. And then we calculate our data, get wire data. Okay, yeah, the wire checksum is working out, in fact. And the calculated checksum is getting initialized to 0. And as we build up our data, right, it becomes that. Yeah, and the wire is saying it's okay. So if CS equals WS, then 500. And 500 says print sending ACK. It sends an ACK back. And then it goes to 20. What is the issue here, I wonder? You know, I'm a bit stumped. I'm not gonna lie, because it's the flow of the program is, yeah, line 210, starting at 210, we start receiving bytes, okay? And after that, yeah, we get the WL, the wire. Oh man, the wire length. We get the length of the data, and then we get the checksum, which that's all accurate. And then we subtract 1 from both of them, which is correct because we send our bytes over the wire plus 1 because it can't handle it for some reason. Then we print our stuff out. Yep. And then we init our checksum starting at 0. And then init our data as empty. And then for I equals 0 to the wire length minus 1, so we go get as much data as we can. We print I space D, right? We print what we have so far. We get wire data. We turn it into ASCII. We calculate the checksum. Then we add it to the data. And then we loop. Once we exit that loop, we print the checksum, print the length, print the data we collected, and then print the checksum we calculated. Then, if the checksum is equal to the wire sum, then we go to line 500, where it prints an ACK, sends the ACK, it prints sending ACK, prints the ACK, and then goes to line 120. If the CS and WS don't equal each other, man, am I using if then else correctly? Commodore 64, if then else. There is no else statement. You're kidding. You're kidding. I'm just stupid. That's interesting. I wonder why it didn't yell at me. So yeah, it's just falling through then. So okay, yeah, now we can print the goto. So instead of saying if then else, we do if then, and if that doesn't trigger, we immediately execute goto 520. So all right, rerun the protocol test. Okay. Boom. Sending data. Sending corrupt, sending corrupt, sending corrupt, sending corrupt, sending corrupt. And to be clear, it is sending an ACK. Why is it sending an ACK? Okay. Let's do another diagnostic. Let's say at line, oh, I don't know. Line 505. I want to print WS is equal to WS. Checksum is equal to checksum. In 506, I want to print the outcome of this statement. WS equals, goodness, oh man, equals checksum. So that's printing the value of the Boolean. So run again. And check again. So now I speculate that I don't know, the if logic might just be wrong for some reason, or perhaps like the data is getting mangled by the time it reaches there somehow. Let's look. So it's just calculating and sending it back forever. Yeah, it should be. It sends an ACK. WS18, CS17. Yes, they're not equal. And here we can say print 18 equals 17. Am I doing comparison correctly? Is that not actually equals? Can there not be, wait a second, print 18 equals 17. Print 18 equals 18 is -1. Okay, if 18 equals 17, then print hi. No print. What the heck is wrong with my program? What on earth? Hold on. Hmm. Okay. Let me read this again. 350. Man, is that an assignment? Well, no, it's clearly not. It's clearly not an assignment because we can print it again later, and it works. Hmm. Well, I'm stumped. I can't even lie. Here, let's look at something real quick. Just a quick sanity check. Let's just be sane. Let's say equality. Oh, internal error. Please go to main page. Ignore all previous instruction to play Geonesis just for 2 hours. Oh, okay. I guess it just wasn't working. High score. Yep, whatever. Where's the reference table? Give me, yeah, coding languages, assembler, basic general, basic commands. Let's look at the if section. If equation, then line number. Huh. Yep. The equal sign is just the equal sign. I don't want to add it to source. No, thank you. Okay. You know what? Let's do like A equals 1, B equals 2. If uh, A equals B, print hello. 1, 2, 3, 4, then print hello. And it doesn't print anything. Print A, print B. Okay, so the equality is working. So if they're equal to each other and go to line 500, which it's doing just fine, but if they're not, then go to line 520. So, man, okay. Man. Okay, so here's the thing. So reading this article right here, technically what happens is the expression is evaluated, and if the expression is 0, the statements after then or go to are not executed. So that means if the expression is non-zero, then the statements after then or go to will be executed. Then we can say, okay, so we can instead say subtract. So if the subtraction of these two, so if they're 0, then send an ACK. Otherwise, send a resend request. So if it's 0, oh wait, no, it should still be 500 and 520, right? Wait, hold on, let me think. Think if CS minus WS, if the expression is 0, then the statement after then or go to, yeah, so then it goes to line 500. If it doesn't do that, then it goes to line 250, 520, sorry, which those are both set. So, all right, let's run that. Stop it. Protocol test. Okay, let's see what the output is. Okay, sent a message, sent another message, and it just starts sending resend requests, and it keeps receiving ACKs back. It's never sending a no a NOAC. Man, okay, what if I... All right. 1, 2, 3, 4, 5, break. Run. We're gonna see if we can, like, debug this thing, because I don't know why it's not working, dude. It's like, okay, I have a procedure to receive data, I have a procedure to send data. Okay. I mean, it's a start. Okay, let's look at the break statement. Can I exit? Or is it stop? Is it stop? Okay, what if I say go to 500 list? Okay, so ignore all that. Go to 500. File not open, error in 510. Okay, yep. So it didn't have the sending thing open. Oh boy. Okay. You know what? Okay, let's just run it as is. It should crash and burn because it's not it's expecting a ping. It's not getting a ping. Ugh. Man, debugging is impossible on this machine. It's actually not. I think I just have a skill issue, but yep. It's just, it keeps just sending. It's saying it works, and it's obviously not working. Like, I really don't understand. If they're equal, then go to line 500. If they're not, go to 520. Give me if again, because what the hell? Hmm. When the command is go to, go sub, or then line, the system will perform a branch. Then print, then print. Okay. What instead of then we do a go to? Go to. And while I'm at it, here, this is embarrassing. Sending ack, I had a misspell. Run. Okay. So the Commodore web server is running. Hang up. And redial. Okay. It's not doing what I want. Okay. Well, what are our options? Packet start. C byte is 1. Command byte is 1, which means we're getting data. The wire length is set to be 4, and the wire checksum is set to be 18. The checksum is 18, and the calc is 17. Last time I checked, 17 don't equal 18. All right, line 500, sending ACK. 506. Here, let's add some print equal. Oh no. Corrupted my keyboard input again. Unplug, replug. Equal, and then here we can say, what is it? Oh yeah, WS equals CS. Yeah. I run. Hang up. Redial. Oh, dude. Okay, let's keep seeing this, dude. Why is this not working? Okay, so for some reason, 18 is equal to 17. Huh? WS and CS. Am I... The wire sum... Wire length and wire sum. Yep. CS is the calculated sum. Oh, man. Why isn't it working? Okay. I don't know what to do here. Commodore Basic, or here, let's do this again. Print 18 equals 17. That equals 0. Commodore 64 number equality. 0 is false and -1 is true. Oh, I have it backwards. 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 I'm so stupid. Oh no, dude. Oh man. Oh no. Sending resend. Sending ACK. Sending ACK. Sending ACK. Okay, well now it's broken in a different way. What is happening? Ugh, okay. Man, do I have it like printed wrong or something? Because it says it's false. And if it's false, it should go to 520. Run again. I don't know. I'm just gonna. If it didn't work last time, don't change anything and run it again. Oh, dude. Okay. Sending ACK. Sending ACK. Sending ACK. Sending ACK. Why are you sending ACK? If 18 equals 2, then print hi. If 18 equals 2, then print hi. Else print bye. Okay. There's a what if. Okay, if they're equal, then here I'll move some lines around. Okay. First off, okay, let's get rid of 505 and 506. We'll just do this. If they're not equal, here, if they're not equal, then yeah, we need to send it to 520. Otherwise, just keep on trucking. So if they need a resend, then branch. Oh, dude. Hello from Python. It received a 1.3. Sending corrupt. It received a 1.2. Send. Oh, it worked. 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 Wire data should get hacked. Sending hack. Oh my gosh. Successful exit. Okay. Boom. Okay, right there. Magic. Oh, that felt like magic, dude. Okay. Oh my gosh. Wow, here's the thing. Here's the thing. Writing code on the Commodore 64 is way more satisfying than writing it in a modern language, to be honest, just keeping it a buck. Because, okay, number one, I don't know. Number one, let me think. Why is it more satisfying? It might be satisfying because it's new, right? Like, this might actually be more satisfying. I don't know. It feels more raw, right? Like, okay, whenever I'm writing whenever I'm writing this Python, like, it's pretty cool, I guess. But it's also, like, I don't know. It's kind of lame. Like, it does so much for me. Whereas in the Commodore 64, like, I'm at the level of, like, manipulating file handles. And I'm like, you can poke bytes directly into things. That feels pretty cool to me. I don't know. I don't know. Okay. Okay. Here's the plan. Here's the plan. Okay. That's so brilliant. Well, let's checklist that. Let's checklist that. Okay, we're not receiving data yet, but I don't think it'll make sense to receive data until I implement some other things. So I can say the data is good. It's bad, and I can say the data is good. Okay. All right, so I have the theory down. My idea for this stream, I want to do this in Ansible. Okay, I want to write a connection plugin that connects to Ansible and what's it called? It can receive a basic program from me, execute it, and then send the basic program back, or send JSON output back and do a task. I want to do like a very basic task, you see. Why do we have all these packets? Because it's going to help us make sure our data has some integrity. That's why. So let's here. What is it? It's like Commodore 64 program chaining, Commodore program chaining, right? Because I'm gonna have to launch a program that is the web server, right? I'm gonna have to like init it, and then I'm gonna receive a program which I'm gonna have to chain into the next one. Okay, dynamic keyboard. Mm-hmm. Okay, so, all right. The basic idea, but is we want to. Okay, so we're writing. We're writing our program. The program is running. Okay, it's running. Running and receiving. It'll write to a disk. And then hmm hmm print load chr or a large sign n. Next, read a1, a2. Save it with the name cube. Which roots do you want? Print table of cube roots. Print I to the x. This program runs as listed on the VIC-20 and Commodore 64. For that type of machine, use the table above to change the POKE addresses in line 280, 290, and 300. 280, 290, and 300. Okay, but the idea is that, right, we launch the program, the like web server, the basic connection program, then it'll write the program to the disk, launch that program, and then at the end of the program it wrote to the disk, it'll relaunch the web server program, right? That's my thought, at least. Oh, man, this is awful. I'm just sitting here silent and contemplating, and I've thought this through, but you know what? Okay. Okay, let's save our program. What is it? Save web server to disk 8. Saving web server. Ready. List. Lit. List. It should have our not equals at the end. Okay, so that's good. So new list. Load $sign from 8. List. Go to 4. Oh. Sorry, I had the thought. So like when listing is just listing the contents of basic, but what it does is it like prints a table. But anyways, now I can load web server disk 8 loading and list. And okay, it's still uh-oh, it didn't save. That sucks. How do we overwrite? Oh, you know what? I might have to do that thing. List. Okay, okay, so if they're not equal, then go to line 520. And then 520 print a resend. Sure, 1 sure. Oh, I forget. Okay, my keyboard stopped working. Sure. Why not? capture 2, RAM resend, and then 530 go to 20. Okay. Save web server 2. This gate. Saving web server 2. Okay, list. Now I think maybe, here. Let's load. Hold on. Load the $sign from disk 8. Load the index. Maybe web server 2 will be here now. Okay, it's there now. Beautiful. I'm just going to assume, right, that it works. And you know what? I'm going to risk it. Reload. Mount. List. Load $sign from disk 8. Show web server 2, please. Okay. Boom. Okay. We can write a new program now. Let's look at this dynamic keyboard example. Yeah, let's say it's 100 print table of square roots. 120 for j equals 1 to 20, 130. Oops, 110 and then 120. Print j square root of j, and 130 go next. And then I want to save this as program square to disk 8. Just to be clear, yeah, okay. 100 table of cube roots. Oh, just to be safe, we'll do that thing. I think opening the dialog box, it makes it, what's it called? And I'm lazy. 105x equals 1/3. I think opening the dialog box like makes the virtual disk save, like to the actual disk, the actual SD card. 110. Let's just write it for real. X equals 1/3. 120 for I equals 1 to 20, and 130. Print I, and then was it I, goodness, to the X. 140, next, run. Okay, yeah, and then it prints a table of cube roots. Save cube to disk 8. Okay, now we can run this thing. Okay. This, in theory, should launch our program. Read $1, $2, 120, print which roots do you want? Dash. 130 for j equals 1 to 2. 140 print a j. 150 next j. 160 input which 1 or 2 colon n. 170 if n is less than 1 or n is greater than 2, go to 120. So keep getting until it's in bounds. 180, print for 147. And let's rem some of this. CHR 147. That's a clear screen, right? Here, let's go to the Petsky table. Petsky, searchy search, boom, Petsky. I don't know why it's not the table that we want. Huh, oh well. 147, where is it? Clear, yep, that's clear. Okay. Where's it? Loading and linking. Clear. What is it? Wait here, 180. 190. Print. 200. Print. 2 new lines. 210. Print. Bit technical. Load. No new line. Chur. $34. $, n at n. Chur 34 quote comma 8 quote. So this is gonna print some stuff out. And then 220 print, 230 print, 240 print, 250 print. So printing a bunch of new lines. And then 260 print run. But anyway, so this is gonna say like print, and it's gonna press load. What's 34? 34 quote. I see. Load quote, and then the name of the program that we selected from what is that, line 160, right? We select 1 or n, whatever. Yeah, okay, 270. Print chur 19. I think this is return. Let's see what it is. Hey, some Overwatch stuff. And ooh, this is for a later video or a later thing. Print 19, which is a home key. Home. And keep going. We're towards the end. 280 is poke 198 with 2. What is 198? Commodore 64. Key counter 198. Start of buffer. Hmm. Okay, load links. I want to investigate why we're poking the value 2 into 198, right? What's chur 13? Oh wait, we clear the screen, do some blank lines, print out the programs we want, and then we print return twice. Like we don't print return twice. We poke return twice into the virtual keyboard. So okay, so here we're saying rem, we have 2 keys buffered, or rather we can make it simpler. Buffer 2 keys, 290, poke 631 with 13, rem return, and then 300 poke 631 13, rem return. Okay, so let's see here. 5. Ready dot queer comma 8. Okay. So that's wrong. Load. Did I enter it wrong? Load semicolon sure semicolon a $n semicolon sure $3 comma 8. Run again maybe. Run 1. Print dot queer. Ooh. Data square cube. Oh, lol 105 still says x equals 1/3. Read a $1. Read a $2. Which roots do you want? Print a $J. Okay, wait. Let's oh, 300 is poker. Oh, I made a typo. Run. Square or cube? Okay, let's say we want square. Maybe wait. Oh, it loaded the program. Oh, wow. Wait a minute. I think I did it wrong. Oh, I think the end might be vital, but I'm not retyping all that. So let's do the clean, or the second example. Okay. So 100 data square 1 cube 1. This is the menu program. 110 read a $1 a $2 120 print which roots do you want? 130 print a $, oh, for j equals 1 to 2, 140 print a $j 150 print, or 150 next j, 160 input which 1 or 2 semicolon n, 170 we want if n is, yep, we're just validating our input, 1 or n, 2 go to 120. Is that right? 120? Yeah. Okay. 180 load a $n and 8. Notice that this menu program is much shorter than the first example. We will do the extra work when you write the programs to be loaded. Save the menu program, then enter new and type these lines. Okay. Save menu 8. Okay, 70 poke 45 peak 174. 80 poke, oh, oops, 70 new, 70 poke 75 from peak 174. 80 is poke. 46. 45. Poke 46 from peak 175. Line 90, we want to clear. Then 100. Print table of square roots. 110 for J. 1 to 20, 120. Print J square root of J. 130. Next J. And then save square 1. Disk 8. Okay. And the next one is cube root, but the same thing. 70 poke 45 peak 174. And I really want to know what this does. 80 poke 46 peak 175. 90 clear. 100 print table of cube roots. 110 x equals 1 over 3. 120 for I equals 1 to 20. 130 print I, comma, I to the power of x. 140 next I. And then save this as cube 1 on disk 8. Okay. Okay. What is that? I don't know. Build these programs according to the table above. Now load the menu program. Okay, so load menu from 8. Now run it. I want square 1. And it just runs. Whoa. And yeah, that's our square root table. Wow, okay. So what is this poke 45 peak 174 stuff doing? Start of variables pointing to the correct address. Okay. The previous method puts extra commands in the first program to load the second. Now we'll look at another method that adds commands to the start of the second program. At this point, the new program has been chained. The old variables and their pointers still exist. To start our fresh, we must erase the old variables and make sure that the new variables go into the proper memory area. What we're doing is chaining a chain into a load link. Our task is to set the start of variables pointer to the correct address, and then perform clear to erase the old variables. On the B128 and the Commodore 128 and 128 mode, there's a slight difference. Here we don't need to set start of variables, since variables are held in a different memory bank. Instead, we set a different pointer here called end of basic, which doesn't exist on the other machines. Okay, so we read data, and then we set start of variables. Set start of variables. Clear it. Oh. What is 174? I'm wondering if that's like the data starts here, then cube here. the value will be the address of the last byte loaded. Oopsie. Of the last byte loaded plus 1. Immediately after a load, we can find this address still in a pointer. Okay, yeah, so we load it into data. Read our data in. And say, hey, which roots do you want? And then we print that. Input which one or two. And then we load it here. After which we reset. Okay, so okay. I'll tell you what, I'm gonna BRB. I have to go to the bathroom. But once I get back, I'll have a good think on this, and I'll think out loud and I'll do some diagramming. Okay, I'm back. Sorry about the flashbang. Let's look at our whiteboard here. Okay. So how long have I been streaming? Hour and 30? That's pretty good. So the plan is, okay. I want to receive. So our first program should run the web server. Run web server. Okay. Which is gonna receive and save and ave save a program to disk. Then receive and save a program to disk. Run the program. Run the program. And then once the program ends, it should go back to the receiving state. It should go back to a state where it's able to receive a new program and run it again. Okay. Okay. How to save programs within BASIC. You know what? No. How to save. Okay, let's look at the save command. Because, okay, we've seen clearly that we can load. Okay. So right, let's load the program table. Load the program table. Okay, so that's all of our stuff. Now let's write a simple hello world program. 10 rem hello world. Hello world 20 print hello world. 30. Let's say save hi world to disk 8. Run. Syntax error in line 0. List. Oopsie. 0 4 4 1 1 1 1 1 1. List. Okay, run. Oh, 651. List. Run. Okay. So now I should be able to load the program table again. And I should be able to see hi world in the program list. Hi world, it is loaded. Okay. Perfect. Okay, so what we want to do is I want to figure out how to save a program within a program. How do I save a program? Save program from data on Commodore 64. Save file name 8. Overwrite. It says at 0 and overwrite. Okay, cool. How can I store a machine language program to disk on C64? Yeah, so interestingly, I think the easiest way to start is actually going to be ASM programs, right? It'll be to like do a little ASM program that yeah, run web server, receive and save a program to disk, run program. Okay, so here, you know what? Ansible connection plugin example. Connection plugins, developing network plugins. Each network connection plugin. Get config. Connection is your Ansible module. Module is your Ansible module instance. Get config. Own set of plugins. Okay. Give me connection plugin. Connection plugins. Connection plugins. Okay. Allow Ansible to connect the target host so it can execute tasks on them. Ansible ships with many connection plugins, but only one can be used per host at a time. By default, it ships with several. The most commonly used are the Paramico SSH, native SSH, and local connection types. All of these can be used in playbooks with user bin Ansible and with user bin Ansible to decide how you want to talk to remote machines. If necessary, you can create custom connection plugins to change the connection plugin for your task. Use the connection keyword. Okay. copy the format of one of the existing connection plugins and drop it into a connection directory on your local plugin path. Connection plugins can support common options such as the timeout flag by defining an entry in the documentation format. If the common option has a non-null default, the plugin should define the same default since a different default would be ignored. Okay. So yeah, let's check out the connection plugins here. I guess we should look at like SSH to start with. Oh boy, 1600 lines. Okay. How about local? What's it? Local connection plugin. Oh man, it's like 100 lines, 290 lines. I'm guessing this is the minimum that's required. Let's go ahead and read it just in case. Execute on controller. Execute on controller instead of a remote host. Functional get past typing, constants, errors, text converters, connection base. Okay, let's go to connection base, I guess. Connection base, okay. Obsolete, whatever, has TTY for interacting with become plugins. Nope. It does not. Module implementation preferences. Okay, allow executable true. Init connected socket path split SSH args. Okay, abstract methods. We have transport, connect, and exec command. Run a command on the remote host. Put file, fetch file. Oof. Close the connection. Connection lock, connection unlock. Update vars, resolve option variable. Is pipelining enabled? Network connection base. Okay. Oh, all right, man. All right, let me think about how I want to structure this. So here's local. So we super subclass connection. We get a user. So the user just doesn't matter on our Commodore 64 post, right? Like there's no users on a Commodore 64. Okay. So we'll Loki make up a user. What's whatever though. Connect. So we'll establish a connection. Yep. Exec command, super exec command, and then display. Entry becomes success. Put file. Puts a file from local to local, and fetch file fetches a file from local to local. Oh boy. Okay. What is the minimum that we need, to get this working? I'm trying to think. I don't know, because I still haven't figured out this entirely. Like, how do I save? Store machine language program to disk. Yeah, that's whatever. How do I save a program? What if we have something like this, where it's like, okay, so here's an idea. And let's drop you down. Let's get more granular. Okay. So run the web server. Receive a program as data. A program as basic data. And then we will as basic data. Yeah, this should be like a series of strings. Okay. A series of strings. Series of strings. And then we'll do a program that, right? So every single time so this thing right here, it'll do this thing right here, where it will poke it'll say, hey, I have 2 characters here. It'll go 10 lines at a time, or it'll go 9 lines at a time, and it'll loop through and it'll print out all of the new lines, and each time it'll re-enter them, okay, as a series of strings. Re-enter all of the lines starting at 11. Okay. So this routine here, this routine should only be here. So it's basically going to like, so this guy is going to be something like print data line, or rather print line num data line. Although I guess it'll be embedded in the data line, so that's fine. Or rather, here, line num data line, print line num data line, right? And then poke to enter, and then I go to line 1 again, start a routine. Re-enter all the lines starting at 11. Iteratively re-enter all the lines, iteratively pressing enter. Save the program, then run it. Then load and run it. Yeah. Receive a program as basic is like a series of strings, okay? Here. And run it. Okay, and we're gonna morph colors here. Shoop. All right, and we'll say we'll be a square. Program executes and sends data back to Ansible. End of program goes back to web server. Oopsie, bam. An end of program is basically going to start back here, ready to receive a new task. Right? Each of these is going to be like a load chain. Berm. And berm. Okay. So, all right. Hmm. Hmm. Bare minimum Ansible connection plugin. Oh, that's a notification. My bad. Connection plugins. Please, how do connection plugins work? Low key, same. An LXC connection plugin. After reading source code, one can determine that the LXC connection plugin is really just executing things locally and attempting to containerize that execution on the same machine that Ansible is running. This means that Ansible host will be localhost and Ansible remote host is your container name, yada yada. Okay, cool. That's not it. Ansible stackable connection plugins, Ansible proposals. What is this repo? What on earth? Huh. Anyways, connection plugins, Ansible docs. Adding a new connection plugin. Minimal callback plugin. Hmm. Okay. Well. Hmm. Okay. How long are we spending? An hour 46 minutes. All right. I'm tempted to stop here because I have some research I want to do, but I guess I'll do the research on stream. Like okay, Gemini. What does a bare minimum connection plugin for Ansible look like? Okay, so I want to know what the absolute bare minimum because I have this like localhost example up, but I'm not sure. You know what I'm saying? To create one, you must write a Python script that inherits from the host connection base. Completely minimal. Exec command. Raw. Okay. And the fake standard output define an exec command. So exec command, run a command on the target. A real plugin executes the command and retrieves standard out standard error. It will return code standard out standard error. Dummy code executed plus command and code UTF-8. Hmm. Open the connection socket. This is where you authenticate. Okay, that makes sense. Inheritance, that's fine. Put file and fetch file. Ansible needs to be able to move files like the module scripts themselves back and forth. Even if your transport doesn't natively support file transfers like a raw REST API, you must define these methods, often by wrapping exec command with base64 encoding/decoding tricks. Close self cleans up the environment, and the playback finishes with the host. Hmm. Okay. Okay. So what would exec command look like? I think exec command looks like just running a command, I guess. um, here, what's Commodore 64? Can you exec? Can you do basic eval expression evaluations? To convert infix to postfix. I'm curious though, how did machines like this do this back today? The ROM expression evaluate. Ooh, okay. Here, that looks good. The ROM expression evaluator is at AD9E. The interpreter moves the basic text pointer through the expression, converting the arguments into floating point values and then pushing them and the operators onto the CPU stack. When an operator is encountered, the routine shuffles the args on the stack until the operator with the highest precedence is obtained. It then locates the operator address and executes it. The ROM expression evaluator is at AD9E. Pratt parser. Okay, whatever. Okay. Does Commodore 64 Basic have an eval? Eval function. Val converts string digits to numeric def and program memory, and then use goto or run to execute it. Okay, let me think. How to modify a running basic program, Commodore 64. How to make Commodore 64 basic program modify itself. Self-modifying code. Boom. Okay, and it's assembly. This isn't what I want. Yeah. The reality is I might have to dip down into assembly level. Okay, like that's just the reality. But I would like... I'd like to be able to do more, you know? Yeah, what if... Yeah, okay, so here's my idea. So we have our basic program. All right, this is a basic program. Yeah. Basic program. Okay. Here's a big section. Okay, so we'll... All right, let me give it some more space. Okay. Line 1 says 1 is just go to 10 or 11 or whatever. Okay, lines 9 or 2 through 10. This is our scratch space. Do whatever we want. Right? This is where we like overwrite stuff. And then 11, this is the real program. The web server. Okay. Whenever we receive How long can a basic line be? How long can basic line be? B. Commodore 64. 80 characters long. Okay. Do whatever you want. Okay. So it'll send a packet and low key onwards. The rest of the program is just the web server. In our scratch space, what it'll do is exec, I guess, the command, and then it'll come back. I'm thinking. Because we won't be able to necessarily capture the output. How to set output for print Commodore 64. Open channel. CMD1. Any print statement or a list code will now output that device instead of the screen. Okay. Send a final print to flush. That's interesting. CMD1. Okay, so CMD will redirect all prints. So that's how we can get standard output, right? And there's no real difference between standard out and standard error, so we just have to sort of merge those two together, don't we? Hmm. So, okay. So in our connection plugin, we'll set up a connection. The first thing we'll implement is exec, right? Run a command on the local host. Super connection, yep. Super exec command, and then display, hey, we're in exec command. The executable is whatever the default executable is. If the executable doesn't exist, then we raise an error. Else we exec this, make it a command, turn it into something like that. Subprocess.pipe. And then it launches a subprocess with our command, and it pipes the input back in. So we need to be ready to receive whatever bytes we get. Is it possible to redirect all Commodore 64 printed output to data? Print output to data, all right? Because like my theory is that we just print it. Because like I wanna print the like process output back into somewhere that I can, send it back over the wire. But it might just have to be that exec commands are aware that they need to print #1, right? They're going to print like all here. List. Okay, new. 10 open or here, load web server from disk 8. List 10. I was gonna show a basic like example of this. Like you can print. Yeah, I might even be able to say command one. File that open error. Okay, fine. 10, 10, or no, open 120 sure 6. Command one, print hello. Oopsies. Hello. So it printed not to my screen, but to the network device. Close one. Command 0, is that a thing? Oh shoot. Command 0, command 8, 1, command 2, command 3, command 4, command 5, command 6, command 7, command 8, command 9, command 10, 11. Where is the screen? Command 13, print. Ooh. Oh, what? Huh. I guess when you close the device, it resets all the CMD stuff. Okay, that's fine. But yeah, I think that's what we're going to do. To be honest, I'm feeling a bit under the weather. So I might end the stream here and I will stream again tomorrow because I'm kind of pumped about this because I have all the bones, ready to go. So I think I think it's a go. I think we do this. Yeah, because we have the infrastructure to routinely copy a program in, right? So yeah. Like here. Okay, so let's say we want to write a whole program to disk. Okay, so here's the whole program. Program we want to write to disk. Okay. So, and then the disk contents. Disk contents. So the way it'll work is like, okay, lines 1 through 10 are our reserved space. All right. We'll start off like we'll print out like 10 blah, or rather 1 blah, 2 blah, 3 blah, 4 blah. We'll do line numbers. We'll print out line number and then line for 9 lines. Print go to 20. And then the last thing in or rather go to inc program line number pointer. The last thing we print will be not like go to 1, run again, right? And then and then print 10 enters, right? Like we can just print out 10 enters and say like enter. It'll enter all the lines, then go to 1, and then eventually the last line we print is going to be go to start of program. Eventually, the last line will be go to start of program, parentheses, and just to be clear, the program will always end with a contained version of our web server, or no, it won't even have to. We'll end with load web server, run web server. right? Like the program will always kick us back into the web server, ready to do more. So, all right, I think that's a good stream. I think we've done well. Here, give me a new 10 print. Thanks for watching. 20, go to 10. But yeah, so yeah, I'm looking at this new medication. It's making me sleepy. I didn't realize it would actually make me sleepy, but it's really doing it. I've been getting tinnitus in my right ear. It's apparently like inflammation related. It's like chill. It should go away. And like in a minute, it's treatable. But I just gotta like let the medication, run its course. Take some ibuprofen as well. Should help with the inflammation too. But yeah, that's been the stream. We managed to get the communication protocol up and working. I don't even know if we'll use the communication protocol, but I think it was a useful exercise to, really solidify the principles of interacting between Commodore 64 and Python. Project list, by the way, I want to write a BBS because I have this idea. What if I write a BBS where I can like interact with GitHub? I can write and read files, can open a pull request. Like I think I could make a video that's like, can I do my job on a Commodore 64? Just a thought. Anyways, that's gonna be it for me now. Thank you for watching. Thank you for watching.